Welcome back. Today we will be talking about the composite functions. Composite functions are nothing but the combination functions. So combination implies instead of talking about only one function, we are combining more than one function. So we can perform all the arithmetic operations with these functions. So when I say arithmetic operations, we are talking about adding, subtracting, multiplying, and dividing, right? So as I said, we are talking about more than one function, right? So let's take example of two functions. We have f of x and g of x. With these functions, let's understand the arithmetic operation one by one. So first, if I have to add these two functions, what I have to do, I just have to add f of x plus g of x and then combine the like terms. And when you combine the like terms, you will get x squared plus 4x. As simple as that. Then we are saying subtraction. Let's subtract. So basically we can do any arithmetic operations with the functions, right? Composite is a little bit different than this. Composite is one function inside the another function. It is a combination. So these are the basic operations: adding, subtracting, multiplying with more than one function. You are multiplying them, dividing them. So with the multiplying, we need to be careful when we are using either the distributive property or if you might have learned FOIL method in your class. So whatever method you want to use, that's totally fine. I will be using the distributive property or distribution method in this case. So I will take 2x and the whole entire second bracket, then plus 1 and the whole entire second bracket. And you can solve it to get the lovely answer as 2x cubed plus 5x squared minus 1. This is plus. Right? This is how you will multiply the two functions. Let's divide the two functions. And for dividing the two functions, let's take some other example. We have f of x and g of x. So when we are dividing the two functions, we are saying f of x over g of x, or f over g x, right? But with dividing, we need to consider something called domain of f of x and g of x, because we need to make sure that the domain is not equal to 0. Otherwise, the denominator will become 0. And when the denominator is 0, that is called undefined. So domain of f of x and g of x, and make sure it is not 0. So let's try to find the domain of f of x and g of x separately, and what combination of domain we can consider for dividing these two functions. So domain of f, so the function f of x is radical x. So radical x, it's the square root of x, right? So x should be greater than or equal to 0 because it's a square root function. You cannot take the square root of a negative number, then it will become a complex number. Now what is the domain of g? So inside the radical we have 4 minus x squared. So that should be, so x is greater than or equal to negative 2 but less than or equal to 2, right? So that is the restriction for g of x function. But from the domain of the f and domain of the g, we can conclude that we cannot take x is equal to 2, because if I take x is equal to 2, it will make g of x as undefined. So we cannot include x is equal to 2. So the domain for f of x divided by g of x is closed circle for 0 and open circle for 2. So x should be greater than or equal to 0 and less than 2, because if it is 2, then it will make 0 as the denominator, which we don't want. Right. So a little bit careful when we are dividing the two functions. Now let's jump back to the composition function. This is just a basic idea, right? Recap of how to apply different operations on the functions. So the composition function, as I said earlier, it is a combination of two functions. Combination of two functions. So we have two different functions, and we are writing the two functions one into another. One will be the inside function and one will be the outside function. So let's understand it. Let's understand with an example. We have this function. So when we are writing the composite function, we are saying f of g of x, or the another way is a open dot between f and g. And how to read it? We say this is f composed with g. So f is the outside function and g is the inside function. That's why it says f composed with g. Write it down in here, and so that because you need to be able to read it properly. Remember, f is the outside function and g is the inside function. Okay, so if I say f composed with g, that means g is inside. So in this example, what is the inside function? 4 minus x squared, because g of x is 4 minus x squared. So 4 minus x squared, it becomes your new x. So in f of x function, I will replace x with 4 minus x squared. Because f of x is x plus 2, so replace x with your new x. And new x is 4 minus x squared. So this will be, and this is the composite function. That means f composed of gx. So this will, if you solve it, so f composed of g of x will give you a new function which is negative x squared plus 6. So how I got negative x squared plus 6? Because I used a minus b whole squared property. So this is the basic of writing the composite function. Now few things you need to understand. So remember few points. This is f composed with g. Can I also write g composed with f? The answer is yes. But do you think f composed of g will be equal to g composed of x every single time? No. They might be, they might not be. So remember one thing. Order is very important for the composition function. You cannot mix match the order. So in the above example, we calculated f composed with g. If you solve g composed with f, you will get a different answer. Let's see. So order is very important for composition function. And the second thing is, be careful what is the inside function and what is the outside function, because we work from inside out to solve the problem. And this is extremely important even from the calculus point of view, because in calculus, when you will be calculating derivative, then in the chain rule we apply the same rule, working from inside to outside to solve or to find the derivative. And the third, be careful of the domain. because we cannot outrightly reject any domain. You need to consider the domain restriction as well. So let's take the above example only. So in the above example, we had f of x is equal to x plus 2, and we took g of x as 4 minus x squared. So earlier we solved f composed with g. Now let's solve g composed with f. So how to read? G composed with f. G is the outside function and f of x is the inside function. So this is your inside function f of x, which will become your new x. So you can say this is equal to g, and instead of f of x I will replace with x plus 2 because this is my inner function. Let's write it down. G of x plus 2. This is your new x. But what is the original g function that is given in the problem? The original function is 4 minus x squared. That means I will replace x squared with x plus 2 squared. So x plus 2 whole squared. And apply a plus b whole squared property for x plus 2 whole squared. And you will get 4 minus, in the parentheses, x squared plus 4x plus 4. Combine the like terms and you will get negative x squared minus 4x. And you can see from here, this answer is different from what you got previously for f composed with g. So that is why order is very important. There will be cases when both of them will be equal, but that will be discussed in unit 2.7 when we will talk about the inverse function. Because when they are same, f composed with g or g composed with f, and they generate the same value as x, then it becomes the inverse function. But we will discuss about it in 2.7. But remember, order is important. Now it's your turn. Try one example, one problem for yourself, and be careful when you write the composite function. This question asks for find the domain of f composed of g for the functions and please write the domain first before you write the composite function. So the two functions are these, radical x and g of x is x squared plus 4. So let me give you one hint. So try to graph the function and check the domain of the composite function. You can write the domain first and then you can graph it, maybe on the graphing calculator, or you can use Desmos to graph it and see how the two functions are behaving individually and see where the domain restriction is there. And then when you write the composite function, see how the function should look like. So give it a try. Composite function. Right? Now the another important thing in this chapter is called decomposing. So with the decomposing, it is going backwards. That means the composite function is given to you and they will ask you what were two initial functions. For example, they might give you f composed of g and they might ask you what is f of x, what is g of x, or they might give you g composed of f and they want you to tell them what is g of x, what is f of x. That process is called decomposing. To understand decomposing, what we need to understand, we need to look at the function and identify what could be the inner function and what could be the outside function. So we have x minus 2. right? So we are writing as a composition of two functions. So in the denominator we have x minus 2. Can I say let g of x be x minus 2? And if g of x is x minus 2, that means that is a inner function. So we are taking let g of x is the inner function, which is nothing but x minus 2. Now, if x minus 2 is the inner function, that means the outside function f of x will be because then now the new x is x minus 2, right? So 1 over x squared. That should be my outside function because 1 over x squared, x will be replaced with the new function which is x minus 2. And let's see if it works with the composite function. So let's write down f composed of g of x. That will give you x minus 2 whole squared. Or you can rewrite it as x minus 2 everything to the power of negative 2. Right? And it works. So the two functions, or decomposing of this function will generate into two functions. The two functions are f of x is equal to 1 over x squared and g of x is equal to x minus 2. So the trick here is to identify what could be the parent, what could be the initial inner function and what could be the outside function. And then you rewrite those two functions together to decompose. Try one question for me and try to decompose the given composite function. So we have h of x as cube root of 8 minus x, everything divided by 5, and write as a composition of two functions. So again, composition function, you need to understand it very minutely in depth, and I will see you in the next video with the inverse function. Bye for now.